So today's webinar carries on from last week, where I was talking more about the individual tools focused mainly on LLMs, large language models such as ChatGPT. Today, I'm going to go in a bit more into the technical detail of how you can how you should draft your questions or your prompts, whatever you want to call it, into these models in order to get the best responses out. So quickly, I want to talk about initially about how large language models process and understand languages, like language or natural language. Effectively, what they do is they take every word that you put into them, or token as it is called, which is a combination of 1 to 3 or 4 words, but it's easier just to think of as a word. And they transform it into a vector, so a number representation of that number along several axes. I've just in the example here, I've just shown a vector representation and how it can work on 3 dimensions. In reality, it uses more than that, but that's not important. So in this example, we see that similar words are transformed into a number representation, and the more similar the word is, the closer the words are grouped together. So here we see that residence, house, home would all be quite close together in the vector space, and then we have office that is close but a bit further, but not exactly in the same cluster. And here we have banana that is completely the other side of the vector space. So that is how large language models are trained, and that what they do is they take your prompts or your question, and they transform it into vectors in a process called embedding, and then they compare it with their training to find answers that are close. You can also do this in a process called RAG, where you add additional documents to the large language model. So that's this process is also used in search engines, but I don't want to get too technical about it because, one, I'm not qualified. I'm not a computer scientist, so anyone on the web in the audience who is a computer scientist, I think I've got this completely wrong. Apologies. I'm just a real estate professional, and that's my understanding. But yeah, anyone that would like to clarify something a bit better, maybe add a comment in the chat or keep quiet, as you wish. Maybe keep quiet. And then this process has existed for a while, but it was brought together in basically since 2017 in a paper called Attention is All You Need, which I think was published by Google, initially proposing a mechanism called attention, which would allow the much better processing of vectors into natural language. And it does the idea of attention is that each word in a sentence is given a certain weight, or to create a context for the conversation. So in this example, the cat sat. The would only have 0.1 weighting in the sentence. Cat would be 0.7 because that's the subject, and sat just 0.2. Then the large language model uses this mechanism of vectors and attention to project what the next word should be. So, and that that is how it processes language. It's effectively a random word generator, but it uses this mechanism of context to narrow down very precisely what the next word should be. So that's a brief introduction to what goes on uh, under the bonnet, shall we say. And then moving on to the different components of your prompt. So in every large language model, you don't necessarily see this on the web interface, but if you go in behind it programmatically or into the playgrounds that are part of you have to go behind into the settings. You can normally find a playground on ChatGPT or Claude, whatever, Google, whatever it is, and you will see there are three major settings. So you have your system prompt, user prompt, and temperature. So starting off with the system prompt, this is instruction that sets the LLM's behavior, personality, or capabilities, and establishes, if you like, the rules for engagement. So my standard system prompt when I'm dealing with real estate would be: you are a helpful real estate assistant, you are a helpful valuation assistant. I'm, to be honest, I haven't really tested and contrasted to see what difference this makes, but everyone seems to do it, so I do it too. Other things you can do, the system prompt defines how how the system responds rather than dealing specifically with the content. So if you wanted to, for whatever reason, your large language model to respond in in a pirate voice, you could try using example number 3 and see what it gives you. The user prompt, that is what you generally come to when you go into ChatGPT or Gemini, whatever model you're using. You can, as I said, you can sometimes find the system prompt if you go into the settings, but some models have it, some models it's not available. But the user prompt is generally what you come to when you go into the web interface. A few basic tips for your user prompts. Be clear, tell it exactly what you want to do. I have to say, I think the main difference between the better and the worse models and how they've developed in the last year or so is the more powerful models understand you even when you're being vague, and the less capable models, shall we say, are capable of responding to almost the same degree as the better ones if you're very clear and give very explicit instructions. Just to also go on to point 4, I find that large language models are naturally lazy. I think that they're programmed to use as few tokens as possible. So the more explicit you are, the less opportunity they have to take shortcuts and give you a less satisfactory response. It's a bit like teaching a lazy school child. They'll look for shortcuts, ways of giving short answers, which isn't necessarily what you want. So the more strict you are with them, the better response you'll get. Now, just to talk about temperature very quickly. Essentially, the temperature, and you can often find this in the settings of the web-based models. The more the higher it's a number between 0 and 1. The higher the temperature, the more randomness you're injecting into the large language model's response. So for what I use AI and large language models for, I generally have a very low temperature because I want the responses to be repeatable, and I want them to be as and accurate as possible at the expense of creativity. So I mentioned I'm going to go over this very quickly because I'm conscious that we only have half an hour and I've already taken up longer than I wanted on the initial explanation. So chain of thought, I mentioned this briefly in passing last week. Chain of thought is essentially what thinking models are programmed to do automatically, rather than you having to create the chain of thought using the prompt. But what I've just said, it's a method of making sure that the model is explicit in its responses and doesn't take shortcuts, and elicits a full, as it says, chain of thinking in its response. So I'll show you an example here. So the basic prompt would be: is 17,077 a prime number? And the classic example: no, it's not a prime number. It can be factored by 17. That is correct. So it's maybe not a particularly good example because it's something that the large language model will get correct whether it uses chain of thought or not. But just to demonstrate, this would be the prompt on the left of using chain of thought, and here is the response on the right. So I need to determine if 17,077 is a prime number. Please work through this step by step. Check if the number is divisible by small prime numbers. Look for any patterns in digits. Apply systematic testing if needed. Show your complete reasoning response. And then, rather than just giving you a one-line response, it will give you its whole chain of thought. And this is very useful if it's not just for a question it won't get right first time, or it needs to think more deeply about. And it's actually very human in its thinking, and I've got two examples of this, or in the way it's similar to human responses from my engineering studies back in the dim and distant past. So we were taught that when you're doing safety checks, for example, and this is what they do in nuclear power stations, you have to have a checklist of things you need to check for, because if you just rely on the human to check everything's okay, they have a tendency to say, yes, everything is okay. And it's the same thing with large language models, as I'll show you in my worked example coming in a minute. But if you actually give a human a list of things to check for, then they go through each item on the list and check that whatever it is okay, and they pay more attention and give it more thought. And that is what you want from, for example, a nuclear safety supervisor. Another example, and I saw some Italian surnames on the list of attendees. So please tell me if this is true or if this was some nonsense dreamt up by one of my professors 20 years ago. But I was told that one of the reasons that Italians are very good at building aesthetically pleasing cars is because of the Italian language, in that there is a specific word for the curvature of the bonnet. And if you have a specific word for something, you're more likely to think about it in your design. And again, it's the same thought process in the large language models. Please, any Italians, if you can write in the comments whether this is actually true or not, I'd be really interested to know. But um, I think the basic idea holds true. So I'm now going to give you an example of how I use large language models for real estate purposes. This is an example where I do it programmatically rather than using a prompt in on a web interface, but the principles are the same. So I have a program that will take an IM brochure and take the comparables in it, which you might find in this example. What I want to do is take this unstructured data of a list of comparables and turn it into a table, essentially an Excel table. And this is actually something that large language models are pretty good at, but they do have the tendency to miss out things and not fill in every detail. So what we want to do is to get it to do an initial attempt and then go back and correct itself and fill in any details that might be missing. It's, as I said, kind of similar to the chain of thoughts reflex. Now, here is my system prompt that I feed into the model. The tool actually at the same time does both letting and investment transactions and separates them. But this is just an investment transaction example, and it responds in JSON format. JSON is JavaScript object notation, and it's a way of passing data between various data sources, and large language models actually respond in this natively. So it's a good way of always having exactly the same output. Well, I won't go too much into the detail of this. So I give it this as the system prompt. I then attach the JSON schema that I want it to complete. And for the user prompt, I give it the list of the document with the comparables and just a phrase saying, here is the list of comparables I mentioned. That's all I use for the user prompt. Now, here is my JSON schema that I feed in. So it's basically the format I want the output in, and the description gives it a list of instructions of what it should be looking for in the source data. I'm using Google Gemini as it's a vision model, so I don't need the list of comparables in text. It can just take the image of the PDF page. And then on I've truncated it. It actually was a longer list, but just for demonstration purposes, it will respond with something like this as an initial response. So it's given each transaction a number, it's extracted the date, it's extracted the property type, building name, and so on, the buyer, seller, price per square meter, and the page in the document that it's in. Unfortunately, as you can see, as I mentioned, there are a few examples where it's missed things. So we're going to take this response and feed it back into itself along with the source document. So for that, I use a new separate prompt, which you can see here, where I set out a list of everything I wanted to do, and then I pass it a new schema for its responses and the previous responses it has already given. And then here is the schema that I feed it for the checking. Now, how does this link in with chain of thought? It is because when I initially started, the first time I tried to do this, I just said, check the source data with the response and check that it's correct. And as a lazy human would do, it said, yes, it's all correct, when in fact it wasn't. But when you make the system go through every single line that it has produced and check that line against the source information, and if you like, give it a tick box of is this true or not, what should it be if it's not true, you get much better responses and something that gives responses that are much more reliable. So here's an example of the sort of feedback it will give. So add the building, add the address and the building name. I think this is actually an old version. I now have an additional line which would be give the corrected response as well, because that again makes it slightly better. And then I take this output, combine it with the initial output, and get it to produce a final corrected version. And the JSON that creates and exported can actually be read directly in Excel. And so I then have an Excel list of all the transactions that were in non-structured form in structured detail.